All right, here is one of the quiz reviews. This is compound events. So independent, dependent, mutually exclusive, overlapping. Okay, so I'm going to put that on top. So every time you see compound events, you're going to be choosing between whether it is independent, dependent, or if it's mutually exclusive or overlapping. Okay. All right. So the first two questions, all right, actually the first four, it says determine whether this scenario involves independent or dependent. Now, it doesn't say to find the probability. All it says is determine whether it's independent or dependent. Okay. So number one, a basket contains 7 apples and 5 peaches. You randomly select a piece of fruit and then return it to the basket. Then you randomly select another piece of fruit. The first piece of fruit is an apple and the second piece of fruit is a peach. Okay, so key word here is return it. Okay, the fact that I returned the fruit means that my second choice doesn't depend on what I did first. Okay, so this is independent. Okay. Number 2, a box of chocolate contains 8 milk chocolates and 4 dark chocolates. You randomly pick a chocolate and eat it. Then you randomly pick another piece. The first piece of chocolate is milk and the second piece is dark. So, key word or key phrase here is that you ate it. If you ate something, can you return it? No, because you're not going to throw up the chocolate back, okay? So when you eat a piece of chocolate, it's gone. You're not going to return it back to its place and then pick another one, okay? So because I ate the chocolate, it is dependent, okay? Number 3, a cooler contains 6 bottles of sports drinks, 8 lemon lime flavored and 8 orange flavored. You randomly grab a bottle and give it to your friend, then you randomly grab a bottle for yourself. You and your friends both get lemon lime, okay? Now, you kind of have to think about this one because I said I got one and I gave it to my friend. Let's say my friend started drinking it already. I didn't put it back in there, okay? Nowhere in this problem I said I put it back, okay? So you're going to assume that he started drinking it because it said he didn't give it back. He just gave it to his friend, okay? So it's gone from the pile. So I'm going to assume that this one is dependent because it is depending on what I chose first, okay? Number 4, there are 8 nickels and 7 dimes in your pocket. You randomly pick a coin out of your pocket, return it to your pocket, then you randomly pick another coin. The first coin is a nickel and the second coin is a dime. Keyword here is is that I returned it. All right, because I returned it means that every single piece was already there to begin with, that was there all along, okay? So I still have my 8 and my 7 dimes. It is independent. All right. Now, I am going to go to number 5 and number 6. Now the directions say find the probability. So I'm going to use what I did in 1 through 4 to figure out 5 and 6, okay? So let's go ahead and read that one. So it says there are 4 nickels and 4 dimes in your pocket. You randomly pick out a coin from your pocket, return it, then you randomly pick another coin. You want to find the probability that the first coin is a nickel and the second coin is a dime. So you have to determine if it's independent or dependent first. Because I said I'm going to return it, this is independent. Okay? Your formula for independent is probability A times probability of B. Okay? You have to go back and you have to remember all the formulas, okay? So independent dependent is multiplying. So probability of A is that I get a nickel. Probability B is that I get a dime, okay? So the probability that I get a nickel is A, B is a dime. So I'm going to say There are 4 nickels out of 8 total coins times, since I returned it, I still have 8 coins in my pocket. And now I'm assuming that it's a dime, which is 4. So I'm assuming this is 16 over 64. Now, on your quiz, you'll be given the fraction that you have to simplify, not the probability, in decimal form. So we would just have to take 16 over 64 and simplify it as much as possible. So I'm going to say this is 1 over 4. So this is my answer. Now, you could also say this is 0.25, okay? But 1 over 4 is what you will see on the quiz. You will see it in fraction form, not decimal form, okay? All right, number 6. A bag contains 3 red marbles and 5 blue marbles. You randomly pick a marble and then pick a second marble without returning the marbles to the bag. The first marble is red and the second marble is blue, okay? So key word here, without returning the marbles to the bag. Let's go ahead and make this consistent. Say without returning to the bag. And then my question is the last one. Find the probability that the first marble is red and the second marble is blue. Okay, so first marble is red, so this is my probability of A and probability of B. Now, the first thing you have to determine if it's independent or dependent. Since it says it's not returning, you are going to assume that this is a dependent problem because I'm not returning anything. So the second roll or the second pick depends on what you chose first. Okay, so the probability that so you're still going to do probability of A times probability of B, but probability of B is going to look a little bit different, okay? Probability of A, so the probability of me picking a red marble is 3 out of, let's see, I have 8 total, times, now since I did not return the marbles to the bag, I now have 7 total marbles to choose from when I go in and pick the second one. In blue, there are 5. So 3 times 5 is 15. 8 times 7 is 56. Let's see what we can take out. So if we can reduce that fraction anymore. I think we might have to leave it, okay? So this would be your probability. Okay? All right, the next section, number 7 through 10, all you're doing is assuming, or not assuming, you are telling me whether they are mutually exclusive or they're overlapping events. Okay, so the first section was independent, dependent. This one's mutually exclusive or overlapping. Okay, now, first question says there are 15 shirts in your closet, 5 blue, 5 green, and 5 red. You randomly select one to wear. Is it blue or green? Okay, so your or, remember your or statements are mutually exclusive or overlapping. Now, we're just talking about colors here, okay? Is it blue or is it green? Can it be blue and green? No. So therefore, your events are mutually exclusive. If you were to have a mixture, let's say your shirt was, let's say you had an option to have blue and green tie-dye, okay? Then it would turn into overlapping events because you have blue shirts, green shirts, and blue and green tie-dye shirts, okay? They can be assumed as either one, okay? Number 8, a cooler contains 11 bottles of sports drinks, 3 lemon lime, 3 orange, and 5 fruit punch. You randomly grab a bottle. Is it lemon lime or is it orange, okay? there is no mixture between flavors here. You're either grabbing a lemon lime or an orange. There's no lemon lime orange flavored. Okay, so your events are going to be mutually exclusive. A litter of kittens consists of two gray females, one gray male, two black females, and one black male. You randomly pick a kitten. The kitten is black or male. Now, you have, let's do blue for boy. I'm going to highlight some stuff here. Okay, so I'm going to say a gray male, that's a blue one, and we have a black male. All right. I'm going to use red as female, so I'm going to say gray females, black females, okay? So I have a mixture of gray, female and female, and I have a mixture of black, female, and male, okay? So now when I find my probability, or when I tell you whether it's which one it is, it says black or male. Now, I can have black kittens that are male or female, or I can have a male kitten who is black or gray. So there's some overlapping there, okay? I can either have a black girl or boy, or I can have a male black or gray. So there's a mixture there. So this one is going to be overlapping, okay? It can be both, okay? So what you're looking for here could be both. You could have a black kitten, you could have a male kitten, or you could have a black male kitten. Number 10, a cooler contains 9 sports drinks, 5 lemon lime and 4 orange. 3 of the lemon lime and 1 of the orange drinks are cold. The other are still warm. You randomly grab a bottle. Is it orange flavored or is it warm? Now, there's 2 different things that we're comparing here. Number 7, we were just having colored shirts. Number 8, it was just flavors of drinks. 9 was colors and gender. 10 is flavors and the temperature of the drinks. So these, number 7 and 8, both had 1 event. Okay, number 9 had 2 events. Number 10 had 2 events, and the events are overlapping, okay? So this one is also overlapping because you could have an orange drink that is cold or warm, or you can have a warm drink that might be lemon lime or orange. So there is a mixture there. Okay, so overlapping. All right, now we're going to have to apply that knowledge to 11 and 12. Number 11, there are 6 nickels and 6 dimes in your pocket. 1 of the nickels and 4 of the dimes are Canadian. The others are U.S. currency. You randomly select a coin from your pocket. Find the probability that it is a dime or it's U.S. currency. Okay, so this one is going to be overlapping because I can have a dime that is Canadian and U.S., or I can have a U.S. currency that is a dime or a nickel. There's some mixture there, okay? So I'm going to say, so my dime is my probability of A, my currency is probability B. Now this one is going to be overlapping, not independent, sorry. This is overlapping. So I'm going to have to do some subtraction, okay? So I'm going to say my probability of A, so the probability of me getting a dime, okay, is 6 out of 12 because there are 6 nickels and 6 dimes in your pocket. I didn't say which one is which, okay? So I have 6 total dimes in my pocket out of 12 coins. I'm going to add it to my probability of B, which is U.S. currency. So 1 of the nickels and 4 of the dimes are Canadian. So that's 5 coins that are Canadian. That means the others, which are 7 of them, have to be U.S. Okay? So U.S. currency, there is 7 out of 12 coins that are from the U.S. Okay? Now I'm going to subtract dimes that are U.S. currency. Okay? So if 4 of the dimes are Canadian and there's 6 total dimes, okay, that means that 2 of the dimes are U.S. out of 12. Okay, so 6 plus 7, is 11, or sorry, 13, okay? And 13 minus 2 is 11, so 11 over 12 is your probability. Okay, so you have to make sure you label which one is US, which one is Canadian, which one is nickel, which one is dime. Okay? All right, number 12. There are 4 nickels, 4 dimes, and 4 quarters in your pocket. You randomly pick a coin. It is a nickel or is it a dime? Okay? Now, it can't be a nickel and a dime together. So you're going to assume that these two events are mutually exclusive. So you're just going to add them together, okay? So the probability of picking nickel is A, dime is B. So the probability of you picking a nickel is 4 out of 12 because there are 12 total coins in your pocket, plus the probability of you picking a dime is 4 out of 12. So this is 8 out of 12, which simplifies to take out a 4 2/3.